And today we are going to use the King's property of integrals to prove the result shown that the integral between 0 and pi of x f of sin x dx is the same as pi by 2 times the same integral but without the x there, and this result has been required once or twice in step examinations. And so I now show a description of the King's property that the integral between a and b of f of x dx is the same as the integral between a and b of f of b plus a minus x dx, and so we now apply this to the example given. And so according to the King's rule on the third line down there, the integral is from 0 to pi of pi plus 0 minus x, inserted in the place where x goes in both parts of the original integral, and I'm now going to tidy this up a bit. And so my integral is now the integral between 0 and pi of pi minus x times sin pi minus x, and I tidied this up further by using the fact that the sine of pi minus x is equal to sine x. And so I now have a slightly tidier expression of my integral between 0 and pi of pi minus x sin x, which I'm characterizing as I, reminding you that that is the same as the integral on the left-hand side at the top there. And now we continue our proof. And so we can now see, if we look at the middle line, that the integral is the integral between 0 and pi of pi minus x f of sin x, which equals the integral between 0 and pi of pi times f of sin x minus the original integral. So if you look at the bottom line, the integral is the integral between 0 and pi of pi times f sin of x minus the integral between 0 and pi of x f sin of x, which is of course minus the original integral. And so if you look at the writing in blue, we can see the integral is the expression in the middle minus the integral. And this leads us to the answer. And so if you look at the top line with a summary of the last line, integral equals the expression given minus the integral. Add the integral to both sides. 2I equals pi times the integral between 0 and pi of f of sin x dx. And therefore, dividing by 2, we obtain the result required, which is that the integral equals pi by 2 of the integral between 0 and pi of f of sin x dx.